So this is Bob Montgomery again, Vice President of Sales Product Development at Genarex. Today I'm just going to walk through quickly an overview of our main product Bylox as well as our secondary product Bylox HT. Shouldn't take too long. Try to move fairly quickly to keep everyone engaged and make it as interesting as possible. First, just a brief bit about Genarex. Our company headquarters is in Alpharetta, Georgia. We were established late 2013, early 2014, and we specialize in using low-cost industrial products and byproducts in order to convert into high-quality additives and fillers for plastics. We expect that we're going to be breaking ground imminently with very large capacity to service a number of different markets. We'll talk a little bit about some of those markets here quickly, who we focus on, who we bring the most value to. First, just a brief description of a bioadditive. What is it? To those that don't know, what is the space that we play in? We are an additive and or a filler. Typically, these products are cellulosic fibers. They have that long aspect ratio that adds stiffness and reduce impact of products. The problems that we've run into in the past is, or that other people have run into in the past, is that with this long aspect ratio, the product doesn't maintain the same performance as its precursor. So if you use it as a resin extender like Bylox is intended to be used, it tends to embrittle a finished product. Also, bioadditives historically are not very thermally stable and generally can't be dispersed easily into different products. You know, this is one of the things that really sets us apart and has made us very excited to introduce the plastics industry to both Bylox and Bylox HT. Bylox itself is a bio-based material certified as being USDA certified as 98+% bio-based. It's based off a corn protein isolate. We can break this into two main products again, Bylox and Bylox HT. It's designed to be a resin extender, which means we retain the original properties of whatever resin we're loading into. Typically, we fit best with PLA and other biodegradable products, low temperature processing products with Bylox. And with Bylox HT, you'll see that we have a much wider window and can participate as an additive or filler to a very robust and versatile stream of different additives. Also, we found that Bylox and Bylox HT both lay up very effectively and disperse very effectively. We can master batch up to about 85%. We've seen some formulations that we can disperse from master batches of 90%, which really gives us a great advantage from an economic perspective to be competitive even now where olefinic products are historically inexpensive, and be a good cost dilution element for both bio-based materials and petroleum-based products from 10 to 30%. Again, I've mentioned a few times Bylox and Bylox HT, so just a quick snapshot of what we are. Both of these are heterogeneous but consistent mixes of products. Both are very low cost. They're designed to be fillers or additives for various different instrumental materials, including polyethylene, which we know is very inexpensive today. Bylox itself has very high ductility. We've seen it be used extensively or very effectively as a plasticizing component. We see processing temperatures actually be reduced and viscosity be reduced with different olefinic and low temperature processing materials. It's also shown very promising results in terms of oxygen barrier in films, which is really interesting for elements like fumigant films. Bylox has an amber base, so we do have a little bit of color. Both products are going to have an opacity that's inherent to them. So that's something that we understand and we go to the market, forthright with. Bylox HT, also heterogeneous. Also, we view as being very competitive in pricing, something that could offer good cost dilution economics to particularly PLA and some of the more challenged resins right now in the low-cost market, but should also be affordable and not affect the finished price point, or perhaps help the finished price point of even some olefinic solutions. We've seen thermal stability up to 250 C. This is an envelope that we keep pushing every day and something that we've made great strides on. There are no material restrictions, perhaps is a little bit misleading because we can't participate with high-end engineering thermoplastics, But within the commodity sector, we haven't found any materials that Bylox HT can't mix with, can't disperse with, and can't process with. For modifications, just looking at the history again, we've moved very quickly to expand. And Bylox HT, our newest iteration as of August 2014, has actually seen several new technological breakthroughs since then, where we've raised the thermal stability ceiling, we've reduced the odor signature and found ways to neutralize the odor signature altogether, and we found ways to couple, blend, and work into different miscible or different systems through all sorts of different conversion technologies, be they injection molding, extrusion, film, blown film, cast, profile, really any type of process, with the lone exception being rotomolding, because our products are just like any additives, don't melt by themselves and such don't tend to stick very well. So one of the big things that we've seen, this is kind of what we talk about when we look at what Bylox HT brings to the table. When you look to incorporate a bio-based additive or filler into a polyolefin, you're used to polyolefins having this very wide processing window where they can go with a low shear or high shear process, they can go with a low temperature or a high temperature material. And the little blue rectangle here that you see is where most bioadditives tend to fall. It's very difficult for them to participate with polyethylene or polypropylene because they simply break down too early. With Bylox HT, we've completely blown the roof off of that assumption. We found that our product can process, this chart here is actually 2 months old. We are well past the window that we even showcase here, and we can process through some of the higher temperatures that polyolefins are processed at. I would speculate that there probably aren't any temperatures that we can't participate in. Our product is also significantly less shear sensitive than the other products in the space, and we do so at a very low cost position that allows us to bring real value without changing the price point of the finished polyolefin solutions. Particle size of raw Bylox is about 10 microns. The fact that the raw product is round in nature really helps us because, again, that keeps the product from having the aspect ratio and orientation that implies different shrinkages onto the different systems that it's going into. That helps us blend into any variety of different products and processes, and really sets us apart from where we typically see our competition fall short. So Bylox and film, this is one of the application spaces that we're very excited about. For HDPE as an example, we do not add stiffness like you would typically see, but we act as a very effective resin extender. Here you'll see in this chart 10 and 20% loaded Bylox in films that ran very smoothly. We can get down into finer and finer film thicknesses depending on what the customer's needs are, and we continue to push that envelope every day. We're very excited with what we can do in both polyolefin films as well as more sustainable plastic films, such as agricultural films. So in the agricultural film space, we think that we add value to both polyester-based products or the biodegradable type products, as well as the polyolefin products. Obviously, the more of a low-cost filler or additive that you're able to incorporate, the more of a price break you get. The more expensive the base resin is, the more significant that savings is. But we've found significantly and consistently that our product has worked both to fill and retain performance, as well as, in some cases, improve oxygen barrier characteristics. Injection molding, also something very intriguing to us and exciting. This is unique to Bylox HT and something that we see vastly superior performance of our product compared to competition. So we're seeing with a neat homopolymer polypropylene a nice improvement in impact. We've also seen that performance replicated with polylactic acid. We've seen, again, the flex modulus not completely changed, so the product still has the same feel, still has great surface, great aesthetics, is slightly less expensive, and processes just as easily at a little bit lower cost. So really exciting for us, something that we think will generate a lot of growth and a lot of interest in applications that tend to take a little bit longer to cycle, develop, process, and close. Bylox HT and PVC, again, something that we're very excited about. The ductile, rubbery nature of both Bylox and Bylox HT lend themselves very well here. We found in PVC, we already see customers that use very highly filled systems. So they're already 2/3 extremely low-cost filler using products like calcium carbonate or talc. We don't look to even displace those products, but rather displace some of the PVC resin or some plasticizer combinations, depending on how the product is processed. We've seen some processes where we can displace the PVC and plasticizer composition by about 33% of how they're loaded into that remaining 33%. So we can take out about 1/3 of that 33% without losing properties and reducing total products. Again, for building and construction, this is important because adding bio-based content allows you to gain LEED credits. We don't have any red list materials on our product. We don't have any change in terms of curl, warp, or any type of structural integrity loss. We haven't seen any type of extraction from the product over time yet, and we've seen certainly a significant cost out from plasticizer and cost parity or reduction from those flexible PVC resin systems. EPDM rubber is also something we're looking at that we've seen some interesting properties around. Both Bylox and Bylox HT seem attractive to this space. We tend to decrease torque and have very little impact on some of the other key characteristics that these rubber products are made from. We've actually seen arguments that we can displace either oil or carbon black from the formulation, as well as potentially displacing a little bit of both, which is new to us. It's a space that we're not as familiar, but something that we're learning and chasing down on a rapid basis. Again, certification status of Bylox. I mentioned this earlier. We are USDA certified as being bio-based. We tested out as being higher than 98%, both with Bylox and Bylox HT. We found that our product is aerobically compostable per the ASTM D6400 certification process with PLA, as well as our product, if it's compression molded or molded into its own component, would also be ASTM D6400 compostable on its own. Our product is not oxo-biodegradable, so it is not going to break down olefinic systems such as polyethylene or polypropylene. Those products that are stable will remain stable, and we haven't seen extraction products from there. We are not FDA approved for food contact yet, but see no reason why our product will not be approvable, since we don't have any products in our formulation or process that would prohibit us from reaching that type of certification. Lastly, just some contact information. We think that we've got something very exciting. We are preparing to break ground, so we're going to be aggressively looking out for customers that want to try this product and incorporate it into their systems. Feel free to reach out to myself or Chris Kennedy to request a sample today. We can provide powders, master batches, and we really work very closely with all the customers that we're developing to make sure that we fit their solution as effectively as possible. Thank you very much for your time. I hope I explained a little bit about what we're doing and why we're so excited about it, and I hope to hear from you soon.